The data provided here are finishing times that were randomly selected from 2 preliminary heats of the 400-meter women's run at the 2004 Olympics in Athens. We want to find and interpret a 95% interval estimate for the difference in the average time for the 400-meter run between the two heats, and we can assume that the finishing times are normally distributed. Why that part is important, that they're normally distributed, is our two sample sizes here are both only 4, and those are very small samples. And so in order for us to be able to use the t-based inference and do the t-based confidence interval, we do need to know that we have normal distributions. So you would want to take each of these two data sets separately, put them in your calculator, and get all the summary stuff. So the mean of those first 4 values for heat 2 is 52.6575. The standard deviation for those 4 values is 2.278. And our sample size is 4. For the second heat, which is heat 5, the sample mean of those 4 values is 52.875. Our standard deviation is 1.38. Again, sample size is 4. Our degrees of freedom we'll use for the t is the smaller of n1 minus 1 and n2 minus 1. Both of those minus 1 would be 3, so our degrees of freedom will be 3. So we can use that to get our t star value from StatKey. Degrees of freedom 3 with 95% is what we're interested in. So t distribution, degrees of freedom should be 3. Click two-tail, and it's already 95%. So you can see we get 3.182 for our t. So we would get an interval from taking 52.6575 minus 52.875 plus or minus 3.182 times our square root of our s's squared over their sample sizes. This gives us negative 0.2175 plus or minus 4.239. So our interval goes from negative 4.457 to positive 4.023. So what we could say here is that we are 95% confident that the difference in the population mean finish times for the two heats is somewhere between negative 4.457 and positive 4.023. So that would be our interpretation there. Does this interval suggest that there is a difference in the finishing times between the two heats? The answer here would be no. This interval for mu1 minus mu2 ranges from negative to positive, also contains 0. And so when we have that, we can't tell if mu1 is bigger than mu2 or mu1 is less than mu2. So confidence interval has negative, positive values. So we can't detect a difference in the population mean finish times for the two heats.